Assalamu alaikum. Today's lecture is related to planning question in ATP, both in IGCSE and GCE O levels. So here I have some questions. For the first question, which is a planning question, it is from IGCSE 2020 and question number 4. Okay, so in planning question, you have to investigate something, you have to find out variation in one quantity with respect to another one. And in these type of experiments, some variables are to be kept constant and they are known as controlled variable. Okay, and before starting with the discussion, you should be familiar with some pieces of apparatus which you may need during the planning in order to solve the planning questions, because actually you don't perform the experiments in the examination, but you should be familiar with the use of different pieces of apparatus like stand and clamp, set square, meter rule, slotted masses, spirit level, etc. Okay, so here in the beginning, I will show you some of the pieces of apparatus which you may need during the planning. Okay, in order to answer the planning questions well. And these things are, first figure here, which is shown here, is G clamp. Okay, it is used to hold some meter rule on the table. Okay, suppose one end has to be left free and the other end is to be clamped. So G clamp is most suitable for that purpose. Here you can tighten up with the handle, and screw will be tightening up, and these are the movable jaws. There are two jaws, one is movable and the other one is fixed jaw. So here the diagram shows the use of it. So how something is clamped using this G clamp. Okay, and this is a normal stand and clamp, okay, which you use in chemistry as well as in physics. See, this is the use of G clamp, how to hold something. One more figure here, that this is the stand, so that it does not topple over. It is made fixed with the help of G clamp. Okay, so this can be tightened up with the help of the screw and the handle. The second thing, again, this is the stand, and this is the clamp, and this is boss. Okay, boss is used to fix the clamp on the stand. Okay. Now, spirit level. What is spirit level? Spirit level actually is used to know whether something is exactly horizontal or not. Okay, so when the bubble here shown in the figure, if it is in the middle, means the surface is perfectly horizontal. Okay, when it moves towards the right or left side, means that side is at little lower level than the other. Okay, if it is towards the right, means right side is at lower level than the left side, or if it is towards the left side, means left side is little lower than the right side, so that can be adjusted accordingly. See, this is more clear diagram of spirit. This bubble moves depending on the level of the surface. And glue tack is used to join few things. In the same way, suppose you are performing an experiment of principle of moment, and suppose your rod is not exactly balanced at 50 centimeter mark and you want to balance it at 50 centimeter mark, the meter rule it is. So at the one end, which is lighter, of course it will be raised, so you can just make it perfectly horizontal. You can put a small quantity of glue tack at that end. In the same way, it can be used to put fixed masses on the ruler, as you will be performing in one of the experiment here. Okay, these are set squares, protractor, ruler, and beside this you need a meter rule as well, slotted masses, etc. Now let us go to the question. Here A student investigates the bending of 1 meter length strips of different materials. She compares how far they bend when loaded at one end. It means you have to keep one end of the bar or strip fixed, and the other end will be free where you will be hanging masses. Here no diagram is given. It means you have to draw the diagram yourself. You have to think how will you adjust the apparatus. Plan an experiment to investigate how the material from which the strips are made affects the bending of the strips when loaded at one end. The following sets are available. The things which are given: strips of wood, plastic, steel, aluminium. Each is of length 1 meter. Okay, a set of slotted masses which will be hung at the free end. A meter rule to note down the distance between the fixed end and the point where the masses are hung, plus how much bending occurs. Okay, a G clamp used to hold the strip to the laboratory bench. Other pieces of apparatus normally available in the school laboratory can also be used. What are the requirements in our draw a diagram to show the arrangement of the apparatus? Explain briefly how you would carry out the investigation, including the measurements you would take. State the key variables which are to be kept constant. Okay, of course, when we find out the relationship between the two quantities, like here we are finding out we are checking the bending capability of the rod. So a relationship is between the masses which are hung and the type of the strip, okay, which will be used in every measurement. Okay, and a diagram to show the arrangement of the apparatus and how you will carry out the experiment, and state the variable which will be kept constant. So like here, I will just write after reading out the whole question, the suitable table and column of heading you would use. Okay, you are not required to enter the reading. Okay, you just, of course, the reading experiment is not actually planned, so you don't have any reading to enter, but you may expect what to write. Okay, what readings you will take. Okay, and explain how you would use the result to reach a conclusion. Okay, whether one quantity affects the other one or not. So which the quantity which are to be kept controlled, which should not be changed, they are known as controlled variable, kept constant. Okay. So first let us see the arrangement and the things which we will need here. Okay, the things which we will need here: apparatus. Majority of the things are given. Okay, G clamp and masses, everything is given. You may need small ruler. And set square. And a meter rule is already given in the apparatus. So these two things may be needed. Okay, and now we have two quantities. One, the variable which are to be kept constant or controlled variables. And dependent variables and independent. Okay, so here we are changing the masses and the bending changes. Okay, the how much it bends. Okay, bending length you can say. So that is dependent length, change in length. You may write it, change in height of free end. And independent, which we change. Okay, like we change slotted masses. So masses. And what should be kept constant here? The dimension of the strip. What else? Beside this, you should keep the distance between fixed end and the point where mass is hung. That masses are not the constant quantity, because masses you have to vary. You have to increase the mass, and every time you have to note down the bending. Okay. So now let us see the arrangement of the apparatus. These are the sorted masses you will use, and beside this you will use G clamps. Here you can have a G clamp, and this is the fixed end and this is the free end. So you can note down how much it has bent. First you note down the initial position, this height, using a meter rule you can note down, and you can use a set square to see whether your ruler is exactly vertical or not. Okay, so I will just here. So to know the initial length, you will use a ruler, and to check whether the ruler is exactly horizontal in level with this or not, what should be the appropriate position? This, okay, and your eye should be at correct level to now note down the position. Beside this, you will need a set square to see whether your ruler is exactly vertical or not. Okay, so here I have placed set square, and you will note down the initial value, keeping your eye in level. Okay, this is the initial position of the rod when no mass is hung. Then later on, you will hang masses. Okay, so of course, this rod will slightly bend. On increasing the mass, bending will increase and the height above the ground level will change. After the one mass is hung here, it's slotted masses, you can vary it. This position where the mass is hung and the point where it is clamped, that distance should remain same. It is one of the controlled variable. Okay, now the initial position, and this is the new position. This is new height. You will note down, and again you will place the ruler, and with the help of set square, you will note down this position, and the difference between the two heights will give you the distance d up to which the meter rule or the rod or strip has bent. Okay, so what will be this d? Value of d will be h naught minus new height. Okay, that new height will be, of course, less than this. So the positions are noted, this d is calculated. Then you will change the mass. First, it was having one mass hung at this end, then you will add more mass. So it will be hanging, it will be bending more, and new height h will be noted down. H naught will remain same. That is the initial height, that every time will remain the same. Then you will change the strips. For suppose first you have taken wooden strip. Okay, wooden strip is taken, then, and later on you will remove this. You will do the arrangement again. Suppose you replace it with the other one which is given in the question. What type of strips are given? Let us have a look at it again. Wood, plastic. Then you will replace it with plastic. Again, the thickness, length is 1 meter, but beside this thickness, width, everything should be same, because they will change the elasticity of the material. If the area of cross section is different, then even if the same rod is taken, two rods of same length and same area of cross section, they will have different spring constant, right? So that is why every for the fair test, you should keep all the factors same. Okay. So this is how you will carry out this one. You will replace the plastic rod then with steel and then aluminum, and you will record the reading. Then afterwards, what will you do? Arrangement of diagram is shown here to you. Variable which are to be kept constant, that is also discussed. Now draw suitable table. That is, now draw the table which is required for this purpose. What will be the table required for this purpose? Hmm. Type of rod. First one was wooden. Okay, dimensions are same, so you don't need to mention the dimension. Now the slotted masses, and here you will take 5 readings for each. One, 2, 3, 4, 5. Okay, so masses, and I suppose you start with 10. Remember, you don't need to mention the readings. Masses, what unit will be taken? Grams. Okay, and distance D, bending, or distance D, that will be in centimeter. So that you will record whatever comes. Of course, when the masses will increase, the distance D will also increase because the rod or strip will bend more. Then next will be what? Suppose plastic. Same masses will be repeated, 10, 20, 30, okay. And of course here, because the type is different, so elasticity will be different. So D in this case will be different from the previous ones. So that is how you will carry out your investigations. Okay, and what may be the, sometimes the precautions are also asked. Let us see whether they have asked for the precaution. Okay, then depending on the conclusion, how will you use the results? Of course, for the rod for which D increases more, it bends more. Okay, it's the bending capability with the masses is more. Okay, so there is no precautions are asked in this question, but for the safe side, I will tell you the precautions here. Suppose masses may fall, they may fall on the feet. So the ground should have some sand, okay, so a tray of sand just where the masses are hung on the floor, okay, just below the position of the masses, so that if any of the mass falls, okay, and you may wear goggles just to keep your eyes safe. Suppose something just scatters and moves towards you. So these are the precautions. In the same way, surrounding temperature should also remain same. Why surrounding temperature should also remain same? Because the temperature will change the bending capability of the rods. Okay, and each material has different capacity of bending depending on the temperature. Right, so these are the some precautions which you may need. Now let us go to the next question. A student investigate. This is again also from this IGCSE. Previous one was also from the IGCSE. Student investigates. In this lecture, actually, I have taken most of the questions. First two questions related to mechanics. Okay, so this is also related to the same topic, mechanics, general physics. Student investigates how the horizontal distance traveled by a meter ball after it rolls off the end of the plastic track. Okay, so this figure is showing the tracks. Here the diagram is given. Okay, and the ball rolls down the plastic track. The left hand side of the track is fixed. Okay, and the right side can be adjusted. Okay, so that the ball comes off the track at different angles. So it means this can be bent. This part of the rod, the track can be bent, angle has to be changed. Okay, plan an experiment to investigate how the horizontal distance traveled by the metal ball depends on the angle. Angle will be changed for this. It means the ball is not to be changed. Every time you have to use the same ball, and every time you have to keep it at the same position. Okay, because when you keep the ball, suppose here, Okay, so you should put a mark at the position where you will be placing the ball every time. Okay, because if this changes, that will affect the motion of the ball and the track also. Okay, so that will always remain same. This should not happen once you have kept it here. The other time you keep it somewhere here. So that should not change at all. Okay, and moreover, beside putting some mark on the track, you can just mark the vertical height. Okay, this is the vertical height. Every time you place the ball, you note down the vertical height. What will be the vertical height? Let us have a look at it. Vertical height will be this. Suppose you are placing the ball here. So this is the position. Every time you place it, you note down this vertical height. And how will the ball go? This will go this way and this will follow this path. Okay, so it will fall somewhere here. So that distance is the range. Horizontal distance is to be noted down every time. So when the angle of bend is changed, the distance d, that is the range, will change. Okay, so it may be more than before or it may be less than before depending on the angle. Okay, and where it lands, that should also be noted down. So what will you do? You will need a protractor here to note down the angle. You will need what apparatus you will take here. Let me write, let me first see which sets of apparatus they have already provided. Track, withstand, boss, and clamp. This is given metal balls. Okay, and rest of the things are not mentioned. So it means we have to choose more suitable apparatus for this purpose. So in order to note down this, you need a ruler to note down this vertical height. Okay, and measuring tape to note down the range. D, that is range. Horizontal distance. Range is horizontal distance where it lands, where it hits from the track, end of the track till the position where it hits the ground. And where it hits the ground, then how will you know? It means you should have some, this region should be having some, what do you say, some tray which is filled with sand. So you can keep this, and this is full of this sand, so that there will be some depression. There should be some uh, uh, position will be marked due to the ball hitting the surface of the sand. But after you take one reading, you have to flatten the sand so that that depression is no more there. Okay, otherwise you will be confused with the previous or new positions of the ball. Okay, and using the meter rule or measuring tape, you can measure this distance. Okay, now let us see what will be the piece of the track, how it will be moving the ball, how will you place the ball, and how this will be moving. Okay, this was the previous diagram. See, this is the ball. So this is the position where the ball lands. So this distance will be d. Okay, and after you note down this d, you will take a ruler and change the angle. Okay, so this is d, and you place the ruler and bend it little more, change the angle. In this diagram, this angle is about 10 degrees, and then you can make it 20, 30. This is how you will keep on changing the angles. Okay, so we have discussed the pieces of apparatus which we need, additional apparatus required we have discussed, and what should be kept constant in this experiment. Apparatus is mentioned. Which variable should be kept constant? Type of the ball. You have to use same ball every time. Okay, ball should not be changed. What else? The position from where the ball is released, that should also be same. Okay, and then you have to draw the table with suitable column headings. Okay, let me first write down the things sorry, the controlled variable. What are the controlled variable? ball, same ball, position, initial position of the ball, they should remain same. Okay, and what will vary? What will you observe in this? The quantities which are to be observed are angle, of course, serial number, mm, angle of bend, range. That is D. What will be the unit? Centimeter. If it is more than centimeter, you can write meter also. Okay, so these angles, no need to write the values. And this is the second column, angle in degrees. This should be D. Okay, what should be the language of your method in both the experiments? What will you do for method? Adjust the apparatus. You have to write as if you are ordering someone or you are ordering yourself. The language, first I will, student will, or first it should be not allowed. Not preferable. Okay, what is preferable? Adjust the apparatus according to the diagram. Adjust the angle of the track. Angle of the track. Then place the ball at marked position. Okay. Release the ball. So if they are written in points, like first you have written the heading of apparatus, then variable, what is dependent and what is independent. What is dependent here? Angle of bend or the range. Of course, independent is what we are changing. We are changing angle of bend. So this is independent. And this is dependent. Okay, apparatus, controlled variable. After writing apparatus, what will you do? You will write controlled variable, dependent, and independent, then method. Okay, and method, which if it is written in point, that will be easy for the examiner to read. Mark the release the what I was saying here regarding the method, release the ball and note down the position where it lands. And note down the release the ball, note down the position where it lands. Where it lands. Okay, or measure the distance. Next point, it will be there. Then what will you do? For the same angle, you can do twice or like one may be the trial reading. Okay, then you may repeat this reading for the same angle. Then you will change the angle. Then what will be the next point? Change the angle of track, and then release the ball. Same procedure will go on. Okay. Now let us see what is asked in the question. readings are not to be written. Okay, we have drawn the table, explain how you result to reach the conclusion. Okay, so you will see what is happening when D is changing. Okay, when D is, when angle is changing. When angle is changed, what will happen to the value of D? Okay, so this, let us have a look at the diagram once again. So if this is the greater angle, what may be the chances? The ball, the D will decrease. Okay, so this kind of relationship you can guess for the results. Okay, and any precautions? Again, what will be the precautions? In this case, temperature control is not necessary in this type of experiment. But the precaution every time you should place or release the ball from the same position. Okay, and the track should be tightened up properly. Okay, table should be exactly horizontal. Okay, how can you check? You can check the two ends. Okay, it means the track is exactly horizontal. Let me go to the diagram here in the question. Yes. So how will you note down whether the track is horizontal? We will may note down the vertical height at the two ends. Okay, this height, if it is same at the two ends, that means the track is table is exactly horizontal. Okay, so these are the few precautions, and you may wear gloves just for the safety purpose, but there is nothing to prick into your hands, so that again is not very necessary. Sand is already being used, so if something falls, that will fall on sand, not on your feet. Okay, now let us go to next question. See here, this is given selection of metal balls. Okay, so but here, what is the relationship? What you have to investigate? You have to find out the relationship between the angle of the bend of the track and the range. Okay, it means masses, different types. It means if you are given number of balls, you have to take that is one type of ball every time. Don't change. Once you have chosen one, that is to be repeated for different angle. Okay, same ball will be used every time. Okay. Now, this question is from it says June 2023, and this is variant 42, and this is O levels. Now, at IGCSE, a student investigates the time taken for ice cubes to melt when they are placed in a beaker of hot water. Okay, plan an experiment to investigate how the thickness of the cardboard insulation around the beaker affects the time taken for the ice cubes in the beaker to melt. Okay, the following apparatus is available. The quantity of water here, the supply of hot water, supply of ice cubes, thermometer, stopwatch. Okay, stopwatch is for recording the time. Supply of 2 millimeter thick cardboard sheet. It means there are number of sheets available, and suppose you will increase the thickness by increasing the number of cardboard sheet. Explain briefly how to carry out the investigation. State the key variable which should be kept constant. Okay, so any additional apparatus have they asked? No, it is not asked here. Table and column. Okay, so what should be kept constant here? The every time when you take the ice cubes, you should have same temperature of same quantity of hot water. Suppose this is the beaker. Mm, okay, and this contains hot water. Okay, and this hot water, every time for every experiment, you use same quantity of hot water and there are ice cubes in it. Suppose we are using 2 ice cubes. So same mass of same quantity. What should remain constant? Same quantity of water every time. Same temperature of hot water. Room temperature will affect. But here you are using the sheets, paper sheets. So that is to prevent heat loss to the surrounding. Okay, but that is third factor, room temperature. It should remain same. What else? If you are varying the thickness, each sheet should be of the same thickness, which is given already in the question. Same quantity, same temperature of ice cubes. Some ice cubes may be below room temperature, some may be exactly, sorry, below zero, or some may be exactly at zero. Same temperature of ice cubes and same mass of ice cubes. Because more mass of ice cubes will need more heat to melt of ice cubes. Okay, so you will here insert this thermometer in this to note down whether the temperature is same or not. And there you will use a stopwatch to record the time. After you immerse the ice cubes in it, you will record the time. Again, the language will be what? Method. Take 200 to 250 cubic centimeter of or 100 cubic centimeter, whatever quantity you choose, you have to take every time the same quantity. Okay, because you are provided with 250 cubic centimeter of water, means you have to take the water from this available quantity. So this is the total quantity of hot water which is given to you. It means if you are taking the say 5 readings or 3 readings, then what will you do? You will take 70. Okay, so that is how you will be able to take more quantity. Or if you take 50, you can take easily 5 readings. Okay, so if you take 50 cubic centimeter of water, you can take 5 readings from this. So every time you will take 50 cubic centimeter of hot water at the same temperature. If it is boiling water, means every time the water should be at 100 degrees Celsius. Okay, so you will use 50 cubic centimeter of hot water. In beaker. Note down the temperature. Okay, and turn the stopwatch on. And record the time taken by ice to melt. It means the whole ice has to melt. Okay, then you will record this time. Then you will replace this with the new fresh water at the same temperature. Okay, and one thing which I have not mentioned, you have to wrap the paper sheet around it. Okay, so you have taken. Okay, so suppose you have taken wrap the beaker with single sheet Okay, then turn the stopwatch on and record the time. Then what will you do? You will remove this water. You will take new fresh water, new ice cubes, and then double the sheet. Why we are using sheet? So that heat from the water goes only to ice cubes. Okay, when the sheet is thin, some heat may be lost to the surroundings. Okay, so that is to just investigate that more thick sheet will prevent heat to loss to the surrounding, and the entire heat from water will go to ice cubes. So what will be the suitable table of values in this experiment? Uh, Number of sheets, because other factors are same. Number of sheets, or you can write thickness also, or thickness. Like one sheet is 2 millimeter thick. So when you increase the thickness, double the sheet. So 4 millimeter, 6 millimeter, or thickness. Number or thickness you will record, and melting time. So of course, melting time will be shorter when the sheets are more, because the entire heat from water will go to the ice cubes. Okay, if the sheet is only one layer, then some heat will be going to the surrounding, and ice cubes will take longer time. Right? So this is how you can investigate. No values are to be written in this. Just you have to write down the conclusion. What will be the conclusion? And when the number of sheets or thickness of sheet increases, what will be the melting time decreases, because entire heat, more heat goes to the ice cubes. Okay, here you need to wear the gloves because this is hot water for the safety purpose. No, it is not asked in this experiment. Are there any precautions? So we have written, we have done all the required parts of this question. Okay, key variables, the method, the apparatus required. Okay, so everything is done. Now that is enough for today. So Allah Hafiz.